All right, AP Calculus, time to get rocking and rolling, out of controlling. It's another Mr. Birdo video coming out to you, instructional video. So this is coming out to you on Friday, okay, which means I believe we have 2 weeks and a day more of AP review after that, something like that. There's going to be another take-home assignment. You got a take-home assignment that's due today, okay? Make sure you upload it by midnight. And then I think I'm going to assign another one that's due Monday by midnight. I got to make sure you guys are doing work, okay? I see low views on my YouTube videos. So once again, you're watching this, so you're not one of the people who aren't a view. You're a view. Tell other people to view, okay? You're not going to do well in this AP unless you view these videos. And if you do, trust me, you will get the AP score that you desire. We're talking about differential equations and slope fields today. A little bit of implicit differentiation we'll get into tomorrow. I can't stress to you how much I think you're going to see something like this on the AP, okay? You're supposed to have two big part 2 questions, one bigger than the other. And, one might actually have a bunch of short answer and stuff like that. Their way of trying to make up for part 1 problems. But I would be willing to bet money right now that one of the part 2 problems is going to be a differential equations problem, okay? It's a great non-calculator type of problem to do. It's very, very popular. Let's dive right in, okay? So that's what we're talking about today. We're going to talk about differential equations. Slope fields are obviously involved. Hopefully you print it out or you're looking at, what you actually have, as far as the dittos. If you couldn't print it out, it's going to be difficult to do part A, but it's not too terrible. Consider this differential equation right here. I considered it. Let y equals f of x be the particular solution of the differential equation with the niche condition f of 0 equals 1. And they tell you the function f is defined for all real numbers. And that's important because they tell you a portion of the slope field of the differential equation is given below. Sketch the solution curve through the point 0, 1. Remember, a slope field, it's a way to model a general solution. A general solution is infinitely many particular solutions. They only say it's a portion of the slope field because in between all these little snippets of tangent lines, you're going to have more tangent lines, okay? Really an infinite number of points. So they can only, really show you a portion. And obviously there's more of this that goes outside these boundaries right here. But they tell you the function f is defined for all real numbers. And they want you to sketch the particular solution that passes through the point 0, 1. And look, you're not even going to solve the differential equation until later on. And even if you do, it's also difficult to know without a calculator what the heck this thing is going to look like. That's why we use the slope field, okay? All you want to do is try to draw the solution curve so that it actually follows the tangent lines. Do it the best you can. It really does not need to be perfect, okay? Probably looks a little something like this. Okay, moving to the right and then moving to the left, follow those tangent lines. Probably maybe a little something like this. So once again, not something that you need to be perfect with. Every now and then they have you do this. Years ago, we did this once during AP, not even AP review, during the differential equation slope fields. I didn't really draw in a solution curve during AP review. Everybody lost their mind and yelled and screamed at me like, how do you draw in the solution curve? That was this year, 2014. But really, not so terrible to do, okay? It's only a point for that as well, but a point you should get. Part B, write the equation for the line tangent. Equation for the line tangent should be a joke at this point in time. To the solution curve in part A at the point 0, 1. Then use the equation to approximate f of point 2. I don't know f of point 2. Some people are like, well, let's get f and then plug in a point 2. Well, you could get f, but you have to do that in part C. So it'd be kind of silly for them to ask you to do that in part B. Remember, if you want to approximate a function, you don't even want to know what f of point 2 is, right? You just want to approximate it. If you want to approximate a function at a nasty x value, construct a tangent line at a friendly x value close by and plug the nasty x value into the tangent line. And that's known as local linearity. Don't give me no disparity, children. A little bit of coffee. So look, you just need to, they even tell you where to construct the tangent line at the point 0, 1. So x equals 0. So let's actually get the equation of the tangent line. First we need the slope. Right, the slope of the tangent line, slope of the tangent line, take the derivative and plug in. People are like, I don't have f of x. How am I supposed to take the derivative? Well, you have the derivative. They tell you what dy over dx is equal to. It's in terms of x and y. It's a good thing they give me x and y. Let's evaluate it at the point 0, 1. It's really the slope right here, which is impossible to tell just by looking at the graph, besides the fact that it's a positive slope. So if we plug in x equals 0, y equals 1, we get 3 minus 1 times the cosine of 0. And look, no calculator here. Technically you could leave it like that. I'm not going to lie, okay? But it's not going to really help you out later on. 3 minus 1 is going to be 2. The cosine of 0 is 1. So, 2 is the slope y'all looking for. Second, let's get b. That means we plug in a y equals mx plus b. Replace everything but the b, okay? So we know that m is equal to 2. And look, we know x and y. This is so luscious right here, 0 and 1. Thus, we know b is equal to 1. Okay, so that means it's easy to get the equation in the tangent line. We know it's y equals, 2x plus 1. Usually I say therefore, even though there are 3 dots, but you don't need that there. And remember, if you want f of 0.2 to approximate it, well, just, if you're really close to the point 0, 1, the function f, whatever the heck it is, and the function 2x plus 1 are almost exactly the same. So plug your 0.2 in there. And even I can't mess this up. Actually, you know what? Just box that in. You don't even need to do this, okay? Remember, you don't need to compute things on a part 2. Technically pretty easy, right? 0.4 plus 1, which is 1.4. But even that, it's easy to make a silly mistake with. I would leave it this way. You could even take out that 2 and put in 3 minus 1 quantity times cosine 0 and have that right there as well. It's kind of silly, okay, at that point, but you could do stuff like that and you wouldn't get penalized. So try not to worry so much about the calculation, even though you'll have a calculator close by anyway for your specific AP exam. Part C. Find y equals f of x, the particular solution of the differential equation with the same initial condition. Okay, so let's get a little bit of practice here with solving differential equations because it's been a little while. And this is also something that I didn't teach you in class, right? This is a quarantine lesson right here. But really, I hope you went through the work, okay? I hope you didn't just give up on this year here. Things happen like this from time to time. Your life is going to go on, okay? And these are important formative years, especially as far as your education is concerned. It's like I've said in the past in the videos, if you got stuff going on at home, I get it, I do. But if not, if you want to distract yourself from things, come right here, okay? Do well in this AP exam. You really can. Then after that, you really be satisfied as far as your work in the class the last 2 years was concerned. You didn't torture yourself for 2 years to slack off now, right? Right, Zane? No slacking off. Right, Samara? No slacking off. Why did I only single out those two? That seems really, really weird, right? Everybody else, stop slacking off, okay? Watch these videos. How many eye rolls did I just get? Let's cross multiply. dy times 1 is dy. Remember, you want to separate and integrate, but just cross multiplying does not mean that you separated, okay? Separated, and don't forget Mr. Berto's tips and tricks, put the dy on the left-hand side. Separated means you want all the y's with the dy, all the x's with the dx. This 3 minus y, you can't just bring the y to the left-hand side. You got to bring the whole 3 minus y. You could divide by 3 minus y on both sides. I like to multiply by 1 over 3 minus y, because then you put the dy next to it. It sets you up nicely for the integration. And now we are separated. Remember Mr. Berto's tip and trick number 2. If there was like a 2 over here or something like this, I'd multiply by 1/2 on both sides. I always keep the left-hand side as clean as possible. When you integrate here, remember integrating a quotient, the bottom's not being raised to a power, think ln, all right? And if you take the derivative of the bottom, you could see you end up with -1. What constant do you multiply that derivative by to create the top? Well, -1 times another -1 will give you 1. So it's going to be negative ln absolute value, the denominator, usually plus c. But don't forget Mr. Berto's tips and tricks. Keep the c on the right-hand side. You're just going to bring it over there anyway. So it's not necessary to put it on the left. In a world of integrals, cosine is the good guy. All right, his integral is going to be sine x. And then we could actually add some cookies to that, okay? Now, this right here is indeed a general solution. But the thing is, I can clean it up at least a little bit. Left-hand side, I always leave as clean as possible. Let's get rid of that -1, multiply by -1 on both sides. Okay, and then the negatives cancel. We get ln absolute value, quantity 3 minus y is equal to negative sine x. And remember, -1 times a constant, just another constant. That's the general solution I'll be using. Because think about it, right now to solve for y, you have to make both sides an exponent of e. That's an advanced algebraic technique. I don't use an advanced algebraic technique until I solve for c. People are like, well, you multiplied by the -1. That's not an advanced algebraic technique, okay? That's simple right there. Now, if x is 0 and y is 1, I could plug in here, right, to solve for what c is equal to. 3 minus 1 is 2. That's a positive number. We're going to talk about that later. So the absolute value of +2 is +2. So the ln of 2 equal to the sine of 0 is 0. So you actually get that c is ln 2. It's a very popular value for C when you're dealing with an LN type of situation. Not always, but it shows up a lot. Now let's go back to that original general solution we had. General, start. Got to salute him. Negative sinks. So many sinks are normally operating in the boys' bathroom. Breaks my heart to say that because I haven't been in Glen in so long. I miss you guys. I miss everybody. It is what it is right now. The important thing is that you're healthy and safe. Let's make both sides an argument of E. So we're going to E both sides. And you got to be real careful with the absolute value because we know you get absolute value quantity 3 minus y is equal to e to the, why did I put plus c over here? Okay, remember I solved for what that was, ln2. All right, so e to the negative sine x plus ln2, that quantity. 3 minus y, the absolute value of that could equal two different things. The absolute value of 3 minus y could be equal to 3 minus y. That's only if you have y values inside here that generate a positive value or are 0, right? Because you could just take an absolute value of 0 by dropping the absolute value signs. So if y is greater than or equal to 3, you're going to see that if y is less than or equal to 3, pardon me, you're going to see that this thing right here is positive, okay? Or it's equal to 0, in which case you can still take the absolute value by dropping the absolute value signs. If y happen to be greater than 3, then you need to negate what's in there. Remember how you negate a binomial? We talked about that a lot last year. The thing is, think about what y is equal to. In this case, y is equal to 1, right? And I know y is 1 is less than 3, so that's how I know the absolute value of the quantity 3 minus y is just going to be 3 minus y. You don't need to even write it up that way. Just think about it. Is this thing going to become positive or negative when I plug 1 in for y? And you can see over here, when I plugged 1 in for y, I got a positive 2 back. That's how I know you just dropped the absolute value. If f of 0 is equal to 4, 3 minus 4 would be negative, okay? In which case, you'd want to put a negative 3 plus y right here. Doesn't show up a lot, and if it's a part 2, you only talk about losing 1 point if you flub that up, but still something to think about. That point could be important. A multiple choice, that point's very important. Obviously, you'd lose entire credit. You won't see multiple choice, but in the past, it was that way. Remember, you don't need to do this. Usually, it's only a multiple choice thing, but it's great for part 2s. They're always looking for this anyway. When you have addition of exponents, that means like bases have been multiplied. So now we get 3 minus y is equal to e to the negative sinks times e to the ln2, which is just 2, right? So that's 2 e to the negative sine x. A lot of different things you could do here. Let's just put one more step inside here. I'll actually add y to both sides and subtract the 2 e to the negative sine x from both sides. All right, and that's going to be my answer right there. Now it's in y equals f of x form. You could still say y equals and then put this on the other side if you want. That's the symmetric postulate. If you get one like this is not a bad problem at all to have on your AP exam. This is a 9 out of 9 possibility right here. The 2011 problem, this one was rough, okay? 9 points for these problems. I want to say the average score here was 1.6. People really took a dive on this problem here, and maybe it's just because they got too intimidated by it. It's really not too terrible a problem. Don't get me wrong. There's some filthy stuff, okay? Part A is actually not too terrible. Part B is a little tough, okay? We'll talk about that. It's only worth 2 points. Part A is also worth 2 points. Part C, which is solving the differential equation, is worth 5 points. That's a spicy meatball, okay? Anytime you got a part 2 differential equation problem, usually the part when you solve the differential equation is worth a lot of points, anywhere from 4 to 6 that I've seen. So here we got at the beginning of 2010, a landfill contained 1,400 tons of solid waste. Here's the interesting thing, my little theory on this problem. 2010 was the hardest part 2 of an AP exam that I had ever seen, okay, in my years of teaching until last year's part 2, which is rough. But this is the 2011 exam. After that, so many people, did terrible on the 2010 exam. I think they took all those AP exams, threw them into a landfill, and that landfill, it's the beginning of 2010, so that would be at the end of 2010, but I still think that's cute. Middle of 2010, right? Around June-ish. A landfill contained 1,400 tons of solid waste. The increasing function, W, models the total amount of solid waste stored at the landfill. Planners, whoever these guys are, estimate that W will satisfy the differential equation, whoop, there it is, for the next 20 years. W is measured in tons, W. And T is measured in years from the start of 2010, which means that 2010 is actually T equals 0. Which is cool, because they told us a lot of stuff here. That first sentence, at the beginning of 2010, that's T equals 0. They tell you how much solid waste the landfill contained. That's an inish condish in disguise. Then they tell you the increasing function W models the total amount of solid waste. They don't give you the function W. They give you W's derivative. They do that a lot on the AP, right? You know, they give you a function's derivative, then they ask you questions about the function. They also tell you it's increasing, which is going to become important later on in a really difficult part of the problem. But anyway, they don't give you what W is. They give you the rate at which W is changing with respect to time, differential equation in terms of W right here, and then W is in tons, and we know T is measured in years from the beginning of 2010. Don't be intimidated. Even if a part of an AP problem seems difficult to you, skip it and go on to the next part. If part A is impossible, people are like, well, I'll never be able to do part B and C. No, it doesn't really work that way. There could be really easy parts later on in the problem. Use the line tangent to the graph of W at T equals 0 to approximate the amount of solid waste that the landfill contains at the end of the first 3 months of 2010. They even tell you the end of the first 3 months of 2010 is T equals 1/4 because people have become so weak with those skills these days. You know, it's not stuff they're really focused on anymore, so they kind of spoon feed you. Spoon feed a little that way. This sounds familiar. Here they told you to write an equation for the line tangent and use it to approximate the function at some x value. Here they want you to use the equation of line tangent to W. It's not f anymore. Now it's W at T equals 0. They tell you to use it to approximate the amount of solid waste at time T equals 1/4. So look, you got to get the equation of the line tangent to W. He's the original, my OG function at T equals 0. So, you know, the first thing I need is the slope of the tangent line. Slope of the tangent line. Got to take the derivative of W. They gave you the derivative of W. It's right here. dW over dt. Here's what everybody flubs up. We want to evaluate that at T equals 0. And then suddenly people look at it and they're like, well, Berto, there's no T here. So what the heck? There's only a W. What am I supposed to plug in? So many people mess this up on the AP exam. Not my students, by the way. My students did very well. Okay, I'm talking about, you know, the nation and international as a whole. Here they tell you when T equals 0, W equals 1,400 tons. So I can really evaluate this quite easily. Okay, it's going to be 1/25 times, W minus 300, so 1,400. Minus 300. And that right there is the slope y'all are looking for. I mean, technically you could leave it set up that way. You know, you guys don't have a calculator anyway you could use. It's not too bad. It's 1,100 over 25. Think about it, 25 into 1,000. You know, 25 into 100 is 4. So 25 into 1,000 is 40. But then, you know, there's another 100 here. So 25 goes into 1,000 40 times. 25 goes into 100 4 times. So that's why it's 44. And that's the slope y'all are looking for. You could leave it like this. You wouldn't be wrong. You could leave it like this. It's just going to make the second part of the problem, getting B, a little bit nastier. So here, you know, even though you technically not supposed to use the calculator, you know, knowing some mental math is very helpful. You guys will be able to sneak the calculator on the side anyway. They can't stop you from doing that. They said it's not a big deal anyway. So who knows what kind of problem they're going to give you. But M is 44. You know, think about it. T is 0. He's in X's spot. And you plug back into the original. You know, W of 0, we know is equal to 1,400. We got that right here. Okay, that inish condition, that's 1,400. So actually, if you left the slope as this disgusting thing right here, it wouldn't matter, right? Because you're multiplying by 0. So 1,400 is equal to B. You know, therefore, even though there are 3 dots, Y is equal to, I know we usually say MX plus B. I'll even do it right here. I'll say M is 44. X plus B is 1,400. Technically, it's not Y, it's W, and it's not X, it's T. So that's really what's going on there. You could write either. It doesn't mean if you leave it, it doesn't matter if you leave it in the abstract form. Just remember, if you want to now use that to approximate the amount of solid waste at T equals 1/4. So W of 1/4 is equal to 44 times 1/4 plus 1,400, which you could easily just circle right there. Maybe you don't even have a 44. Maybe you have this whole thing written out. There's nothing wrong with that. Go on with your bad self. This one's really easy though. Just 11 plus 1,400. So 1,411. If you do leave it as something nasty, make sure you put tons. It does say to approximate the amount of solid waste. It doesn't say what the unit is in. Okay, so you need to actually, the amount of solid waste here, you need to actually indicate that it's tons. You know, believe it or not, part A is really not too terrible, and you should be able to pick up those 2 points because part B is where it gets filthy. You know, part B over here, they want you to find d squared W over dt squared in terms of W. Then they want you to use it to determine whether the answer in part A is an underestimate or an overestimate of the amount of solid waste that the landfill contains at T equals 1/4. Where's this overestimate, underestimate thing coming from? We talked about it, not in class. We talked about it during AP review, the 2008 section 1. I hope you watched the videos, because whenever you actually approximate a function using local linearity, there's a way to figure out if it's an overestimate or an underestimate, and it deals with concavity. If you could realize that a function's concave up at a point, when you draw the line tangent to the function at that point, when you actually calculate, your approximation, maybe at this t value right here, you'll see the true value is that y value right there, right here. If you plug into the tangent line, you get back this value. You'll say you get an over approximation. And anytime the function's concave down, you're going to see that's always an over approximation, because the tangent line's always going to be up top. If the function's actually concave up, and then you draw the tangent line, any tangent line you draw, if you plug into the tangent line, maybe right here, you're always going to get a lower value than if you actually plug in to the function. Okay, so you're always going to have an underestimate. How about overestimate for this one? Overestimate for local linearity when the function is concave down. And when the function is concave up, you're going to have an underestimate, because you could see that the tangent line is always going to be below the actual function, okay? This does not show up that often. Don't start freaking out right now. There's going to be stuff on the AP exam that you can't handle. Don't freak out, okay? But that's going to be used here. Finding d squared, finding d squared y over dt squared, that's just taking the derivative of both sides here, okay? And I said, because I was thinking quotient rule over here, but maybe it's silly to use quotient rule, w minus 300 over 25. So let's write it again. dw over dt equals 1/25 w minus 300. It's actually a lot easier to not use the quotient rule here. When I take the derivative left-hand side with respect to t, I get d squared w over dt squared. Shouldn't bother you. This 1/25, he's a constant connected by multiplication. Just pull him to the side. Take the derivative of w minus 300. A lot of people want to say the derivative of w is w prime. You're not wrong, but w prime is dw over dt. It's a better way to write it. And then technically minus the derivative of 300, which is 0. So you really end up with 1/25 dw over dt. It's not a bad derivative to take at all. It does bother some people. They did say find d squared w over dt squared in terms of w. This is not in terms of w. It's in terms of dw over dt. But remember, dw over dt is equal to this right here. So you could just plug that in. And now we can get 1/25 times, and now I'm going to plug in the 1/25 times w minus 300. And this right here, that's the answer that we're looking for. Okay, if you want, you can simplify it. 25 times 25 is 1 over 625 here, w minus 300. Not so bad. You can get a point by taking that derivative. I think you guys can do it. My daughter's upstairs singing God Bless America. She has a wonderful singing voice. Anyway, so here, now they want you to determine whether the answer in part A is an underestimate or an overestimate. Now, usually at this point, people freak out. And if you do, fine. Move on to part C. It's worth 5 points anyway. But if you want, stay and listen for a while, okay? My estimate was done to get 1,411. Is that greater than the true value or less than the true value? Well, it's all about the concavity, okay? And it's a good thing about concavity. Remember, the second derivative of a function will tell you the concavity of a function. I got the second derivative right here. The problem is, how are you supposed to figure out if it's positive or negative? Well, remember, W starts at 1,400, right? Okay, because they said at the beginning of 2010, the landfill contains 1,400 tons of solid waste. So it starts at 1,400. If W is 1,400, you can see we get a positive value back here. 1,400 minus 300 times 1 over 625 is going to be positive. But then people are like, wait, is it always going to be positive? Because W starts at 1,400. What happens after that? Oh, the increasing function W. So W is always increasing. So W, the smallest it's ever going to be, is 1,400, which means d squared W over dt squared is going to be positive because W of 0 equals 1,400 and W is increasing, ... We could say d squared W over dt squared is greater than 0. And if that's true, that means W is going to be what? Concave up, which means we have an underestimate. You don't need to talk about concavity. You just need to talk about the sign of second derivative. If the sign of the second derivative is positive at the point, that means that you're actually dealing with an underestimate. And if the sign of second derivative is negative, that means you're dealing with an overestimate. So, therefore, our approximation, who can spell, this is where I really lose points on the AP exam. I can't spell or write anything. Therefore, our approximation is an underestimate. All right, so not so easy to do, and that's where people freak out a lot on this problem right here. But really, I wouldn't worry so much about it, okay? And even, it's not going through it, just losing the point for that and getting the point for this, it's really quite fine. It is. If you move into part C, here's where the real money is. Find the particular solution, W equals W of t, so it's like saying Y equals f of x, to this differential equation. And they even give you the initial condition, so even right now, if on part A, you were like, well, t is equal to 0, how am I supposed to figure out what W is? I mean, right now, they're stuffing it in your face, okay? So you should be able to do that. When I was thinking product rule before, I was thinking of writing dW over dt as W minus 300 over 25. And that's the way to write it when you want to solve the differential equation. People freak out. They're like, but now there are W's and T's, not Y's and X's. So what? The dW is like the dy. The dt is like the dx. Always put the dy or the dW in this case on the left-hand side. Cross multiply. And look, this is not set up to be separated yet, okay? We got to bring the W minus 300 to this side and keep the left-hand side as clean as possible. I'm going to divide by 25 on both sides. Really the same thing as multiplying by 1 over 25 and then multiplying by 1 over W minus 300. And that's not really bad to integrate. Okay, this is an ln. We can see the derivative of the bottom is 1. So that means it's just ln absolute value of the denominator. Don't worry about plus c. Okay, equal to integrate 1/25 with respect to t, 1/25 t plus c. I mean, come on, just put a little constant, put a t next to that constant right there. And now there's nothing simple to do. If you want to solve for w in this case, you'd have to make both sides an argument of e. That's an advanced algebraic technique. I don't use an advanced algebraic technique until I solve for c. Okay, and we know it's the point 0, 1400. So w is 1400. Okay, and t is going to be 0. Okay, so it's easy to see that C is equal to 1400 minus 300 is 1100. The absolute value of 1100 is 1100, so ln 1100. That's also important. We got a positive number in the absolute value. So now, after I plug in this value for C, when I actually make both sides an argument of E, okay, so when I, E both sides, make both sides an exponent of E, you get the absolute value of W minus 300 equal to over here, E to the 1/25th T plus ln 11 hundo for shundo. Over here, I know the absolute value is going to be positive because I know W in this case is 1400. It's my screaming daughter. And 1400 minus 300, like we said before, was positive. So take the absolute value of a positive number, just drop the absolute value signs. If W was 200, when t is 0, you'd make this negative w plus 300. Over here, when you add exponents, that implies that like bases have been multiplied. All right, so that means over here, you're really getting 1100 e to the 1/25th t. Then I'm actually going to add the 300 to both sides, and that's what w is equal to right there. Really not as bad of a problem as you might think. Okay, it's not easy. It's not, okay, but 1.6 points, that's what people averaged. I mean, you guys should be able to do part C right here. That's 5 points. That's a spicy meatball. And you should be able to do part A. There's your 7 if you want a 5, okay? And a lot of people here can get a point right here and get 8 points. This might be a little tricky. It doesn't always show up. Sometimes it does, sometimes it doesn't. So once again, put in your work. Make sure you're putting in your work. I know it's frustrating. Try these problems. You're like, I have no idea what I'm doing. I'm only getting 2 points. I get it. It happens all the time. You'll get better and better. We'll get it after we're done with this. We got a couple more part 2 topics next week. I think it's going to end around Tuesday. Then we'll deal with another part 1, probably 3 days of next week. Then that last week before the AP, I'll try to predict a little bit. What types of questions are we going to see? So we'll focus on a little bit of that right there. But look, it's all about you guys putting in your work. Okay, so I really hope that you are, but once again, I'm not seeing the view number I need, so I'm going to start assigning more assignments to make sure that people are doing their work. I got no choice. You got one due today, and you have another due Monday at midnight. And they're going to follow the types of problems we did on the videos. And, you know, hope you had fun. Hope everybody's safe and healthy. Mr. Berto, signing out.